welcome. Thanks for your interest in this R Workshop. My name is Leo Bastos. I have a PhD in soil fertility and precision ag from the University of Nebraska-Lincoln. And now I'm currently working as a postdoc with Dr. Ignacio Ciampiti. And during my PhD, I was fortunate to learn more about R. And currently, I only use R for all my stats needs. And I also kind of related to that, I also got a minor in stats from Nebraska when I was doing my PhD. So this is kind of like all the programming and automation with the stats coming together. And that's kind of what we're going to be talking about today. So first, everybody has all the packages in R and RStudio installed? No problems. And did you guys get my email with the data set and the scripts that we're going to be using today? If somebody has not received those or has not gotten those, please raise your hand now so somebody else can help you. You don't have, Luke, could you help okay, awesome. So anyone else? Because we're going to need those, and if you don't have, we're not going to follow along. Okay, so let me launch things here. So first thing, please open your RStudio. So we're going to see. Let's see if we can. That's over there. Okay. So your RStudio should look similar to this. What I want you to do is, so now that you have RStudio open, if you can just go ahead and double click on that basic script that I sent you on the email. It's called basicd.r. We're going to be working with that. So once you double click that, it should automatically open up kind of like how I was showing mine here. Okay, so first I just wanted to let you guys know, if you did not have a chance to look at the agenda, so this is going to be a 4-hour workshop. We have a whole bunch of information packed into these 4 hours. It's going to be really important that you pay attention and follow along, because if you just blink, you may miss something that is going to be really hard to catch up later. And like we had people from, like, many people that wanted just a basic, many people that want a medium, and some that want an advanced. So we're trying to cover all those. So to better accommodate that, we're starting with this first hour as as basic, and then the second hour is going to be medium today. And tomorrow we're going to have one medium hour, one advanced hour. You can find more about what we're going to be talking about on the agenda that was sent to you. And then, so because this is going to be very packed and lots of information, we want to ask you the following. So if you have a question that's directly related to what I'm talking up here, please feel free to ask me. I will be really glad to answer that if I know the answer to it. But if you have any technical issues that is not directly, is related to what we're talking about, but it may be something very specific to you, we have some people helping in the room. So we have Luciana, can you just raise your hand? Josefina, Lucas. So we have some people spread around that you may ask for, like, very specific things, something that you're facing at that moment that's not applied to everybody. Okay, so the first thing is, so here we're looking at R in RStudio, and maybe you're not convinced yet that R is the best statistical software that we can learn here. Some people use SAS, some people use, I don't know, even Excel for this type of thing. And so just some of the thoughts why I think it's really useful to learn R is, first, it's free. So you don't pay for anything. So R RStudio, all the packages, everything is free. And so if you're learning SAS, on the other hand, probably going to have to pay, or your employer is going to have to pay for you to use that in the future. R also runs in multiple platforms. So it runs on Mac, on PC. When I was doing my master's, I had a PC and I was only using SAS, and I really wanted to learn R. And then I bought a Mac, and then I was like, well, now I really can only use R only if I wanted to install other software, but I didn't want to. So it was a nice transition into R. And there's a very, very big online community and support. So something you're going to learn, well, maybe not today, but you're going to take from this on is anytime you have a question about R or you're trying to do something, even something new that you haven't learned yet, as long as you can ask that question properly to Google, you're going to get an answer. So there's a huge community that helps out with that. And also, one thing that I think it's something good, but some SaaS hardcore lovers think it's bad, is that the continuous development of packages. So anyone, as long as you know how to program in R, you can create your own package. Like I have a package I created for myself. It's not out there, but helps me with a whole bunch of functions that I use. And so, which means that basically anyone that can program can create a package and publish it, and other people can download it. And that sometimes means that people can create statistical packages and they may not know what's going on behind the scenes. And if you don't know either, you may download and use that. So there's no, that quality control is a lot, the bar for that is a lot lower than for SaaS, because SaaS is a private company, so they develop things that they know works and does what they think should do. So that's a point there. And also reproducible research. Have you guys heard about this term, reproducible research? So it's a big topic, I think, and really comes down to, so think of it, if I'm doing my analysis, I don't know, could be SAS or anything else, and I do my plots in Excel, and then I hand you my data, and reproducible research means that if you have my data and if you have my code, you should get to the same exact conclusions that I did, as far as statistically. Maybe not interpretation-wise, but number-wise, you should. So that's what reproducible research is about. And there was a huge case about this, I think it was like 2009, that a group of people, researchers at Duke University, were working with cancer research, and they developed this algorithm that, depending on some variables from the patients, they used this model. It would predict what type of treatment was best for that specific person. And it was a huge deal. It was published. Like hospitals were using it. All the doctors were using it. And then I think it was like a few years later, after they published the algorithm and people are actually using and receiving treatment from that model that they created, they realized there was a huge mistake on the data set. That was because they did not properly document what they did. And so they went back, and in the end, the algorithm was really no better than just random chance to give a given treatment. And so this thing that if I give you my data and my code, you should come to the same conclusions is a big deal. And here we're not really treating people with cancer. It's a lot less dramatic. But still, you want people to be able to reproduce what you did. And having code, in our case with R, is really one of the ways that you can document what you're doing using your code. All right, so that's about basically some thoughts on R. And now, so why RStudio, right? So if you think about it, when you first downloaded R and then downloaded RStudio, if you just open R itself, that's basically just what in RStudio is the console. So R is this window here. That's what it is. Everything else around it is RStudio interface to make things easier for us to look and interact with. So if you guys have already opened your script, you're seeing your script window up here probably. And this is where, so the script is basically where you're going to program, right? So where you're going to write the lines of code, but the magic doesn't happen on the script. It happens on the console. So we have to send the commands that you write up on the script to the console. And the thing is, we want to have a script because that's where you save your code. So you can even do some math here. Let's say, I don't know, just whatever. You can type any command directly on the console, but it's not going to be saved. So if you want to, have your research reproducible, you actually want to save what you're doing, which happens up on the script level up here. So RStudio is divided into these 4 windows. So we've already saw the script up here, the console down here. Up here is what we call the environment. So every time you're creating a new object, it's going to be saved on the environment. You're going to be able to see it. So this is, we're going to be working with this later. You're going to see some of the objects we'll be creating are going to be appearing here. And then this last but not least window has actually a lot going on. So there's a whole bunch of tabs in this specific one. They're going to be very important. So this files one for now, you can just ignore, but we're going to see how that's important later. Every time you create a plot, like a graph, it's going to show up under plots. This packages here tab is really important as well. So as I was asking you guys to install some packages using the install.packages function, you can actually also come and use here this install button that shows something more friendly and not as programming from the get-go that you can use. And this help tab here is also going to be super important. So every time you have a question about a specific function, you want to know the arguments, what you can change, what you cannot, you're going to be asking for help, and that help's going to show up here. So this is a really important place. Okay, so let's start programming a little bit. So if you guys have this script here, oh, and just so you know, let's see. Can you guys see all right? Do you want me to increase the font for people that are in the back part of the room? Okay. So an object is really, you can think of like if you have a number or if you have a name and you want to save that value to something that you can use later, that's basically what an object is. So let's say, you know, the first thing so can you just raise your hand if this is the first time you're using R? Okay, awesome. So I'm going to try to go kind of slowly, but so let me know if you get lost and we can recap some stuff. Okay, so the first thing that we can use R that's really simple is just as a calculator. So if you just come here in a script and you just type a number, let's say 45, right? And then, so on a Mac, well, let me take a step back here. If I told you before that we're going to write on the script, but you have to send that command to the console to actually be read and interpreted by R. To do that, you can either come here on Run, and at least on Mac, the shortcut is Command Enter. So you put your cursor on the line you want to submit to the console and push Command Enter, and it does it. Does anybody know for Control Enter? Okay, so if you have a PC, Windows, Control Enter does that. Okay, so you know, just number 45 there. Now let's just do some simple math. Let's just divide that. So we're going to use the slash. So the mathematical notation is very similar to Excel. So if you've done anything in Excel, it's going to be very similar here. Let's just divide by whatever number. I want to put 13. And then you run this, you're going to see that the result of this function or of this calculation appeared on your console, right? So now let's say for some reason I want to save this result. So this is 3.46 something, and I want to save that on an object because maybe I want to use later for something. So let's call this object A. So just type A, and then in R, when you want to assign something to an object, we use the symbol that is less than dash. So that's the symbol that is like whatever's on the right side is going to be saved on whatever's on the left side. So let's just copy this here and paste, and then run. So we're going to paste there, then I'm going to run this. Okay. So once you run that, you may have noticed that now A is showing up in your environment because you saved that number to A, and A is an object. However, when we ran this line of code here, nothing else appeared on the console. So let's say if you want to retrieve the value of A, you can I'm just going to type A here and going to run it. So that basically prints whatever is in A. Everybody good? Okay. All right, so now I want to create another type of object here. So we're going to call this B. We're going to call it B. I'm going to use the assign symbol, the less than dash. And then let's say I want to save 3 numbers to B. So let's say I want to save 10, 15, 5. So if I just go ahead and run this, it's not going to work. Why? because, so we basically gave a string of numbers, but R doesn't really know how to handle them. So we have to use a function that's called C, that means concatenate. So you basically put together these three numbers and then assign that to B, and then that should work. So now if we print B, so if you just put B there and print it, it's going to return you the three numbers you saved on it. Is it making sense? Okay, so if we just check again, A is just a number, B is a sequence of three numbers. But now let's say I want to create another variable that I want to give a name, like instead of saving a number, I want to save a word into it. So let's call it C, give that the get symbol, and then so you open and close quotation marks, and within those, I'm just going to write workshop. Okay, so now I run that. You can check, you can print C to see what's in it, and then it returns that workshop word, because that's what we saved, right? Okay, so these are all objects that they're basically just saving stuff, but without any structure, right? And we like to think of data frames. So data frames is really what we're going to use most of the time when we're doing research and any type of analysis. So I want to create another object here. I'm going to call it D. And then I'm going to use a function that's called data.frame. Oh, you know what? Something else I forgot to mention before is, so if you open R alone without opening RStudio, there are two things that you don't get as compared to if you use RStudio. One of them is syntax suggestion. So you see here, as I started typing the name of the function, it's suggesting to me a whole bunch of other functions that it thinks I may want to use, right? So this is something that RStudio does for you that R alone does not. And also something that you're already seeing, I just forgot to mention, is that RStudio has colored syntax. So it has different colors depending on what you're doing there. And so for example, something that I also forgot to mention is that if you just want to write a comment, and by that I mean something that is for you to read, not for R to read. So you don't want R to try to interpret it. It's just for your information. You're going to use a hashtag. Just one is enough. I have two just to create some hierarchy level here. So those things are all together here in RStudio. All right, so now for our data frame, let's do this. The first column in this data frame I want to call number. And now because this is inside of a function, so data frame and open and close parentheses, that's the function, right? So now inside the function, we're going to tell the column names and what we want to save inside those column names. So I just added number there. I'm going to say equal, and then I'm calling B. So note here that I'm not calling just the letter B. I'm actually calling whatever was saved inside the object B to now be saved under this column I'm calling number on this data frame. It's a little bit confusing, but it's going to make sense in a second here. So I added a comma there, hit enter, and now I'm going to call ID equal, and I'm going to say C, or object. Something else also for you to be aware is R is case sensitive, which means that if you save something as lowercase and then you try to call it by uppercase, it's not going to work because it differentiates upper and lowercase. All right, so if you got to this point and you run this, you're going to see that now D appeared in our environment. And if we just print it, which like if you just type D and run it, you see that now we have a data frame, right? So we have a column that's called number, and we have a column that's called ID. So now if you just look at this, why does it look like that, right? So if we go back to B and C, I'm just going to put down here in the console just so you can see. So B actually has 3 values, right? So it took those 3 values and wrote as a row under this column called number. However, C only has 1 value. So what did R do there? It saw that one column had 3 values, the other one had only 1. So I basically recycled that 1 value for all the rows. So this is something that the R does, is to recycle values when it sees that there's a gap there. So that's why when we print the data frame, we see the 3 different numbers, but the same ID, because ID is coming from C, which is just 1 value, that's workshop. Everything making sense? Okay. Okay, so if you use any programming language, and R is a programming language that we use for statistics mostly, but if you use any programming language, there are a group of object types that exist. And in R, I'm going to show you some of the most important ones. So the first one that you saw here, let's just call, I'm just going to call this data frame. So the first one that I showed you is a data frame. This is really what you will most likely be using most of the time. Sometimes we use lists, which is something I'll show you later. Sometimes we use matrices, but data frame is really what we use the most. So another object type is a matrix. So I just want to show you here, I'm going to create an object called E. I'm going to use the function matrix. So you type the function and opens the parentheses there and closes. And now for this function, what I want to do is I want to take B, which has 3 values, and I want to create a matrix that the first column are those 3 values, and the second column is just exactly the same. So it's going to be like a 2-column by 3-row matrix. So if we want to basically repeat B, we have to use the C function again to concatenate. So just going to do B and B. And I'm going to say, and this function has an argument called ncol, which is number of columns, and I want to say 2. So if you run this, and then you print it, this is the result that you get. So see how different this is from a data frame, right? So this is a matrix. Matrices do not have column names, row names. It's just a matrix, right? It's just they're just numbers arranged in some fashion. So if we just print again D here for data frame, so you can see the difference of how they're organized, right? So they're 2 different object types. Okay. So I want to show you one very important object type that is a list. So let's create an object called F, and let's use the function list. Okay, so now what we're going to do is I want you to open and close quotation marks and say A. So this is going to be the name of one of the components of this list. And then we're going to say that in this component of this list, I want to save the object A. So pretty straightforward. We're going to do that for B, C, and D as well. I'm not going to be narrating here for you, but that's what I'm doing. C, D. So if you recall, A, B, C, and D are all very different objects, right? A is just a number. B has 3 numbers. C, what is C here? Let's see. C is a word, and then D is a data frame. So they're all very different objects. So let's see what happens when we actually create a list with all this diversity in different objects. So we run that, and if it printed, so if you just put F and then you print it, I'm just going to increase my console so you can see the whole thing. So when I print F, now is using the $ to tell me that it has different components inside of it. And then it's saying $A has this number, $B has 3 numbers, $C has a word, and $D is a data frame that has 2 columns. So lists, the type of object called list is something that you can integrate different types of other objects inside of this thing. Okay, so we're gonna get to the point that's gonna be really important to find out what type of object you're working with. Because sometimes, and you're gonna see maybe today, maybe tomorrow, why that's important. But so how do we actually know if it's a matrix, a data frame, a list, or whatever else? So there is a function called class. So you use class and you use just the name of the object that you want to see what is the class of that object. So if I use class F, it's telling me it is a list, as we already knew. But sometimes it's not obvious, or sometimes you really want to double check what you're working with. So something that is interesting is, so F itself is a list. However, there are elements inside F And each one of those elements are not a list themselves. The whole thing F is a list, but each one of the categories inside of it is not. So let's try if we do F, and then, so as you saw, F has like 4 different things, right? So if we want to subsample or to get inside F and extract just one of those components, we use the $sign. So F, $sign, then already shows us what's inside of it, so you can choose. So let's say, let's try here B. So when I run this class argument here on F $B, it's telling me what is the type of that specific element of F, right? So B, if you recall, is like 3 numbers, and B inside F is the same 3 numbers. So if you check the class of F, that's a list, but the class of B inside of F, it's numeric. That's how R is seeing it. Is that making sense? I know maybe now this is kind of like really boring, but you're going to see how that gets important. Okay, so let's talk about functions. So in R we have objects, functions, packages, then we have arguments inside functions. So there's just some nomenclature that R has that I think, like, if you're just starting with R today, just to learning like those bricks of how you build things, it's really important for you to get on your own, and then after this, learn things by yourself, basically. Okay, so let's just try a function. There's a function called mean. So as you can imagine, it gives you the mean of a list of a sequence of numbers. So we have a sequence of numbers on B, right? So let's just say mean, and then put B inside of that. It gives us one number. That's the mean of those 3 numbers. In this case, 10. Right? So something is a function when it has a name, and then opens parentheses, and then at some point it has to close the parentheses as well. So that's how we know it's a function. However, functions have inside of the functions there are arguments. So let's say in this case here that we're using, we're saying mean B. I'm just going to repeat the mean. And so I have my cursor inside of the parentheses, and I push tab. So at least for me, whatever is in purple here is showing me the argument options of this specific function. So in this case, x, I can just say x equal b, because that's whatever you want to get your mean over. It's going to give you the same result. So this function mean is a very simple one that basically only has one argument that you can specify. But sometimes functions have many arguments, and let's say that this main function had, I don't know, 10 arguments for whatever reason. And let's say that B was the first one, but I actually, you know what? Let me show you something that's going to make more sense than saying this. So let's come to the argument part. So every time there are different phases in R or in programming that, let's say, if you know what function you have to use for something, you just need a refresher on the arguments that you can change. You can use the function help and the name of the function inside. Like if I want to know more about the mean function, I will use help and then mean, and I run this. So then I get all the documentation about this specific function here on the help tab, as we were talking about before. So if we just row here, we're going to see that there's a section under the documentation that shows the arguments. So this function has like x, trim, narm. So it has 3 different arguments basically. So if I provide those arguments in the same order that they were programmed, so that they were coded here, I don't have to explicitly call the argument name. I can just say, because x is the first argument, I can just say b. I don't have to say x equals b. And that's why this and this have the same result basically. Now I wanna give this a twist and show you how things can be different. So let's create another object called b2, and then use that assignment sign. And then now we're going to use the concatenate function again. It's going to have the same 3 numbers as b. So 10, 15, 5. But now I want to add an NA to it. So comma NA. Okay, so yours should look like this. Oops. All right, so now let's try to extract the mean of, so you can think of this as like if you have a study, like your field study, and for some reason you lost information on a plot, let's say. When you import the data into R, you're gonna have an NA on a data frame. And that can have some serious implications on what happens afterwards because of some reasons that I'm not gonna get into now. But let's just check what happens if we extract the mean of B2. It just gave an NA. And that's why R has a specific way of handling NAs. That's the default behavior. So if you have an NA there, it's going to say, there is an NA, I'm just ignoring everything else that's within this group. However, there is a way to change that default behavior. So if we come back here on the help mean that I typed before, and you check on the help side, there is this argument called na.rm. So here says that if I wanted to remove NAs before it does a calculation, if there is an NA there, if I want to remove it or not. And in this case, the default is false, which means it's not removing NAs, and that's why I give it an error. So now if we come here on the mean B2, I'm just going to copy and paste below here, and then we use NARM equals. You can either use T or true. It's going to be the same thing for R. And you run this. Now again, we get our 10. So I wanted to show you this example here, basically to drive home a few concepts that R has. So one is what a function is and what the arguments do. So if I were to do this, R would do exactly what it just did above. So if I say if above here I say x equals b2 and I remove true, so if I run that, it's the same as running this below. Oops, maybe not actually. Oh, it's not. And here's why. So if you look at the documentation again of the function, the order that the function is taking arguments is x and then trim and then NA remove. So NA remove is actually the third argument in this list. And if I don't explicitly say what I'm giving it, it thinks that this true is the value that's going to use for trim, which is not. That's giving an error because of that. So it is good practice to always say what's the argument name that you want to change. However, if it's something you do a lot, it gets tiring. You don't have to say this all the time. Now, let's say that you actually wanted to invert, for some reason, you wanted to invert the order of these. I would have to actually say NA remove equals true and x equals b. So this works, and the function would work, but if I don't explicitly call the argument names, it does not work. Okay? All right, so now let's talk a little bit about, so we talked about what an object is, what type of classes we have for objects. We talked about functions and arguments. So now let's talk a little bit about package. So I asked you guys to install a handful of packages before the workshop. And normally you only install a package when it's either the first time you're installing that, or if you want to update that package. However, all these packages that you installed, if we want to actually use them, we have to load them. And we use a function called library for that. We're going to see more in the second hour here. But that's just so you get some idea of how, you install a package the first time and then you just load it into your environment every time you need to use it. And there are a few different ways that you can install a package. So I asked you guys to use the install packages function and then use the quotation mark and do the package name. So I actually want to ask you here to install with me a few other packages that I found out we're going to need, and I haven't asked you to install. So one of them is called car, like that. So if you please can go ahead and install this package. So and if you want, you can save this on your script, but because you only do that once, it's okay to just have that on your console and not save on your script. So that was one of the ways that you can install. The other way is on this right-hand side, you have the package tab. So if you click on that install button up there, it's actually gonna give you this window, and then here you can type the name. So if I type car here, it finds it, and then I can say install. And what that does, it basically just creates for you that install.packages function and sends it to the console without you having to think about it. So I want to actually ask for you to help me again here. So if you can come on this install that we just saw, that's install yet another package that is called multcomp, like this first one here. Okay, so if we install that, basically just wrapped that into the function that we used the first time, and then it just sends it to the console and installs it. So that's what it did. Everybody okay? Okay. So I want to, now I'm gonna need your help. So I want to create this data here that I'm gonna call this object intro, that stands for introductions. And as you see, we have the columns we have there is name, year, height, and pineapple. So what this means is I'm gonna ask for a handful of you guys to help me out here. And let's see, well, I guess this part I'll just do in the computer, and then we'll go to the Blackboard later. All right, so I'm just gonna, I know, if anyone just wanna raise their hand and be a participant here? No one? What's that? Oh, yeah, we have candidates for whoever raised your hand. If not, I'm just gonna pick people. All right, I know you, but maybe other people don't. What's your name? Okay, so I'm just gonna start here. So year is basically like, what I'm trying to get here is what year of your college education you're in. So if you're doing a bachelor's, it's gonna be from a number from 1 through 4. If you're doing a master's, it's gonna be 5. If it's a PhD, it's gonna be 6. So what's your number? Okay, 5. Do you know your height in meters? What is it in English? 6'5". Okay, 196. That's good. And then, so pineapple is basically, do you like pineapple on your pizza or not? You don't. Okay, so I'll put an N for you there. Okay, so let's see who else wants to participate in this game. Diego. Okay. We need to have about 5 people just to make this interesting. Okay, so Diego, what's your year? 5 as well. Your height? 192. Do you like pineapple on your pizza or not? All right, let's get somebody like an undergraduate student. I know we got some here. You. What's your name? Pedro. Oops. Okay. What year are you in? If like of your undergrad? 5. Okay, well, from Brazil is a little bit different. So let's just put 4, just for, what's your height?
176.
Okay, do you like pineapple on your pizza or not?
No.
Jesus, does anybody here like pineapple on pizza? Okay, I'll get you. Okay, what's your name? Ooh. Okay, sorry, do you want to help me out here? Okay, thank you. What year would you be in? So, okay, so 6 here. What's your height? Okay. Okay, and you said you like pizza on your pineapple, so I'll just put a yes there for you. All right, one more person. Maybe somebody that likes pizza on the pineapple too? Okay, what's your name? Marta. What's your year? Well, so for you it would be 7, I guess, because you're a postdoc, right? So let's put 7 here. Okay. What's your height? Oh, wait. 1.61. And you like pizza as well. Sweet. Okay, so if you got a chance to actually follow along and write this down with me, that's great. And if you didn't, I'll give you a minute here just to catch up. So one very common mistake that everybody makes in R is to either add extra parentheses or forget about some of the parentheses. So just make sure that you're opening and closing things that make sense. So I'm gonna run this and see if it worked for me. I didn't get any errors, so I think my parentheses were all right. And now if I just print this, this is what shows me. So it is a data frame, so it has the name, year, height, and pineapple column, right? So if you did not, I mean, everybody needs to have this data frame from this point on because we're gonna play with this a little bit. So I'll give you a moment here. If you're having issues, let us know, because otherwise you're not gonna be able to follow along. Anybody need help that I can assist? Did it work for you guys?
Yeah.
When you ran, did it work? Oh.
I got figured out.
Nice what? Oh, thanks. Did it work here for you guys? Okay, well, it seems like most people are there. Okay. 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 Can I have a moderator? Can I have a moderator? I mean, does it have to be now? All right, well, it seems like most people already caught up, so let's just do some more stuff with this data, or start doing some stuff with this data set. So the first thing I want to first ask you, before you run it, if we use the function class on this object, what do you think is going to return? What's going to be the value? You can just guess it. Please. What did you say? Data frame. Let's see. That's correct. So it's a data frame. So now, because it is a data frame, there are a few other functions that we can use to better understand this data frame. So one of them is a function called summary. So, oops, I actually wrote wrong. Summary. So if you write that down and then you run it, it's gonna give you this. So it's basically telling you each one of the columns that's inside this data frame, and it's telling you a little bit about them. So it's saying that each one of these names here appear once in the data frame. It knows that year is numerical, so it's giving you basically the quantiles, so a minimum, maximum, median, all the quantiles there. The same thing for height. And then pineapple, if it saw that there are two values there, N and Y, and it's telling you how many each one of them appear. So this is a very, very important function that you're going to be using when you're doing just like starting your data analysis. So another function that's kind of useful, in this case is not super useful, but I'll show you what it does, is called head. So if you say head and then you put your data frame in there, it's going to print you the first 5 or 6 rows of a data frame. So why is this useful? Sometimes, like, I don't know, I know some people in our group have data sets with like 300 rows. And so if you just do like, if you say intro and printed, depending on how the data frame has been coded, it's going to print you 300,000 rows. It's never going to stop, right? So the head basically just shows you the first rows just to have an idea of what's going on, but it's not going to get too complicated. And very similarly, if you want to see the bottom of this, there's a function that's called tail. And it basically does the same thing, but for the last entries of the data frame. Okay, so let's just check something else. If we use the function class, and we call intro again, but now remember that intro is a data frame that had different columns. So if you want to subset one of those columns, you use the $, and once you type that, it's going to give you all the options of headings that it has. So let's go on year. So it's saying that year is numeric. So now let's just erase year. Let's try pineapple. Pineapple is a factor. So every time there is a word involved, so well, let me take a step back. Every time there's quotation marks around that value, it's going to be either a factor or a character, which are very similar types that are Cs, but there are some differences we're going to be talking more about later. Okay, so now, so we have this data set. I want to show you some quick ways of sampling this data frame here. So let's just start by typing in intro, and then I want you to open and close brackets like this. So for every data set has columns and rows, right? And we can sample either rows or columns together or separately. So let's say we just want the first row. The way it works is you can imagine there are like an X and a Y value. So the X value is for rows, the Y is for columns. So if I want the entire first row, I put 1 in the position of the row and I leave Y empty. So if we run this, it returns the first row of this data frame, right? So now let's say I want the first column only. So you can guess from what I just said that, oops, you would leave the first value empty because you want all the rows but just the first column, and then you put a 1 there. And that's what it does. So even though it's showing as a row here, but it's basically all the values of that first column, which was name. Okay, so let's say that we actually want to sample rows 1 to 4, which means 1, 2, 3, 4, and columns 1, 2, 3, which means 1, 2, 3. So when we have a sequence of numbers that we want all the numbers in between, we can use this notation here. So 1, what is the name of this again in English? Colon, thank you. 1 colon 3, comma, 1 colon, oh, sorry, 1 colon 4, 1 colon 3. So if we see here, it got us the first 4 rows, which is basically all we have in this data frame here. I think, oh no, we have 5 actually. And then it gave us the 3 first columns because of this notation. So what happens now if I don't want consecutive numbers? If I want only rows 1 and 4, which means not 2 and 3, and only columns 1 and 5. So we do intro again, we use the brackets, and so we're going to use, so now because they're not consecutive, we're going to use the concatenate function, the C function, and we're going to say 1, comma 4 inside of the C function. And then outside of that, the parentheses of the C function, you add a comma, and then you open again another C function to tell what columns you want, and then you put 1 and 5. Okay? So if we run this, well, there was an error. Maybe we don't have 5 columns. Yeah, we have 4 only. So let's do 1 and 4 on both. So if we run that, we get rows 1 and 4, columns 1 and 4 as well. So we're sampling both on rows and columns. Okay, so now let's play a little bit with this data set here that we had. So I'm just going to put again, we're going to print up there, and then I want to ask for help one more time. Okay, so this is the data we have, right? And now I'm just going to scribble here. So let's say we want to plot this data. Okay, we want to have a plot and include as many variables as we can on this plot. What would you put on the y-axis? Height? Okay, so sorry, I don't think you can really see that well. Try one more. Okay. Okay, maybe this will work better. Okay, so we're gonna put I is gonna be equal to height. What do you wanna put on X? What? Name. Great. Okay, so I'm just gonna have 3 examples here just to be easier. So let's add here Chris. Let's add Mindy. And let's add Diego. Okay, so I'm just going to kind of eyeball this. So Chris, I think, is the tallest one. So let's just put him somewhere here. Then Mindy. So Mindy and Diego. So Mindy's going to be, let's say, around here. And Diego is going to be like around here. Okay, so right now we have 2 variables that we're showing on this plot. How do you think that we can incorporate if they like pineapple or not? What could we change on this plot to make that happen? But how? But how could you show that difference on the graph? Different colors. I like it, different colors. So let's say if you like pineapple, you're red, and if you don't, you're black. So let's say here. So I guess Mandy is the only one that likes, and then Diego and Chris do not like. Okay, awesome. So how can we incorporate year now? Shape? Nice, I like it, yes. So let's do here, let's use the red one for now. So let's see here. So Chris is 5, Mandy is 6, and Diego is 5. So we're gonna basically have, let's say, so 5 is gonna be 1, and then 6 another. Let's say that 5 is gonna be X, as we have already. I can just put this, and then whoever is 6 is gonna be a dot, right? So we can just basically change this. Okay, awesome, thank you for your help. So you can see now that on this very, very simple plot here, we're showing 4 different variables just by having something on X, something on Y, different colors, different shapes. And that's kind of what I wanna show you in R right now. So when it comes to plotting in R, there are basically 3 different, I guess, philosophies to use. So one is what is called basic R, which is the simplest way. It was the first one that people started using when R came out, but it's not. I mean, to me at least, it is not the best one. The other one is called lattice, like lattice, not the vegetable, like LATTICE. It's a package that has a whole. I mean, it adds a little bit of a taste to what Basics does, but it's still not quite there, at least for me. And the third one that I use, and many people I know use, is called ggplot 2. So ggplot, it's called like this. So if you install the tidyverse before this workshop, ggplot is one of. So tidyverse is basically a collection of packages that all follow the same philosophy, I want to say. And so ggplot is one of them. So it's already inside of the tidyverse. And so if you install tidyverse, you already have ggplot. And so here's another distinction to make for you. So you install tidyverse or ggplot for this matter once, right? But then every time you want to use that package, you want to call the functions inside the package, you use the function library. So that's what we're doing here. That's basically loading ggplot on your current R session. So please do that. And the way that, so I wanna invite you here to make a plot. So maybe let's try to make that plot there, okay? So the way that we do that is we first start with the function ggplot, and then it has some arguments here. So the first one of them is data, so you can just use that, and we're gonna say intro, because that's our data frame. You can add a comma, and then hit enter again, and then there is the second argument called mapping. So after you enter the mapping there, I want to ask you to type the function AES and open and close parentheses. So what AES does is basically stands for aesthetics. So every time you want to change something that's related to kind of like what we were talking about, what goes on X, what goes on Y, how are you given color, how are you given shape, you're going to use, it's going to be within that AES function. Okay, so let's just basically do what we did there. So on X, we're going to say X equal, and then you have to say the column name that has the height. So if we just like print down here intro, well, I guess it was there already. So height is right there. So you can just copy and paste. If you try to type yourself, and for some reason you misspell height, or you use lowercase instead of uppercase H, it's not going to work, just so you know. Okay, so we say what goes on X, let's say what goes on Y. So we say Y equals, oh, I'm sorry, I made a mistake here. So the Y equals height, right? X equals name. So I just changed that. So you see here how I changed the order of the arguments, but because I'm spelling out the arguments, it's gonna work. If I were just saying height, comma, name, it was gonna put height on the X and name on the Y. So you know. Okay, so this is basically how you get ggplot started. So let's just run this and see what happens. So as we were talking before, when you're running like a graph on our script, the result's gonna show up under this tab here called plot. So, okay, what do we have here then? So what ggplot did basically was to put name on X, put height on Y, but it didn't add anything else, right? What's going on here? Well, the thing is we didn't ask it to add anything else. So it gave us the canvas that ggplot has, but now we have to tell it what we want it to add. So you come here to the end, to the last parenthesis there, and you add a plus, and then hit enter. Okay? So what ggplot has is different geometries that you can add. So you can think as a point, a line, a bar plot, a box plot, even a map. Each one of those have their own geometries. And the way that ggplot that we tell ggplot which one we want is we type geom, that is short for geometry, use underscore, and you can see here a huge list of options that we can use. And this is really powerful. It's one of the ways that ggplot is very powerful. So now let's just add a point. So there is one that's called geom point. If you just hit it, it's gonna just do that. And you can just, so once, because we have this plus here, even if we just run this first line, it's gonna actually try to run everything after that, which in this case is just geom point, because it knows that it is expecting something to come after the plus. So I'm just gonna have my cursor anywhere in these two rows and run it, and then it's gonna run. Cool. I mean, now we basically added a point, right? That's what we asked it to do. So now what we gotta, let's see. We are gonna, so the pineapple is colored. So how do we say that we want the points to be colored according to pineapple? So let's say if I wanted to change the color of all points, I could just come inside geom point, say color equals, and then you have to use the quotation marks, say purple. So now we basically changed the color of all points to purple. But in our case, it's not gonna work because we have two different colors that are gonna be coded according to the values of the pineapple column, right? So how do we do that then? We can just basically delete this color equals purple here. And this geom point also has an aesthetics function. So let's use AES again, and now inside geom point, and let's say color equals, let me just print again here our data frame to copy the column name, pineapple. Okay, so now I'm gonna run this. Look at that. Cool. So now it looked at our data frame, it saw whichever rows had an N on the pineapple column, gave that a color alone by itself. We didn't have to tell it. And it saw each one of different values and assigned a different color for each one of those values, right? And then gave us a nice legend there. Okay, so let's see now. So now we want to give a different shape, a different symbol of the dot according to the variable ear, right? So for that, we just come right after pineapple here, add a comma, and then there's going to be an argument that's called shape. So if we say shape equals ear, let's see what happens. Ooh, problem. What's going on here? So if we check our intro, let's just check the class of intro $ear. It's numeric. So how are you going to give like a category, like a different type of shape to a number that's continuous? R, or in this case, R doesn't know how to handle that. So one thing that we can do is to, and this is where like knowing the class of the object is really important. And here's very silly, but it comes times an analysis that makes a huge difference. So for R to really give a different shape to different ears, we have to transform that ear into a categorical variable. And in our language, that is a factor. So I come right after shape equal, I type factor, and I open and close parentheses. Just make sure that you have enough parentheses at the end here. So it kind of looks like that. You have to have 3 parentheses in the end. And then we run that. And now it worked. Very similar to what we had on the board. So that's kind of the idea of ggplot. So you start off with what goes on X, what goes on Y, and then you start adding layers. So you add a plus at the end of that row, hit enter, add another thing, plus enter, and this way you kind of build your plot line by line, using different functions. Okay, let's see. Oh, and just something else I wanted to call your attention to. So all of these, so color, shape, size, different aesthetics that you can change. If you put that, like if I say color equals pineapple inside the aesthetics function, it knows that it has to look for that variable, look for the levels of the variable, and do whatever you're asking to each one of those levels. So even give a different color or shape or whatever. However, so you don't have to delete it. I just want to show you. So if I just go back to the beginning that I don't have aesthetics there, and I say color equals pineapple. So now because I'm outside of the aesthetics function, it's actually looking for an object called pineapple, which does not exist because that's a columnar data frame. And this is why it's important to remember that if you want to change something according to a variable, it has to be set inside of the aesthetics function. However, again, I just want to show you, well, let's just use a different example now. If I wanted to change all shapes that would not be according to a variable, I can just come here and say shape. So shape, there's a list that, I don't know, has like 30 or more different shapes, and they go by number. So I'm just going to type here 3, just so you can see. So it basically 3 is that cross shape. So it gave that same shape for every entry of the data set. So it's just like if you want to apply a change to the entire data set, you'd say that outside of the aesthetics function, and it has to be a value like 3 or purple. But if you want to code that according to a variable, it has to be inside the aesthetics function, and instead of a value like 3 or purple, it has to be a column name that is in your data set. Does that make sense? Okay, so this is a very quick introduction to ggplot. I'm going to share with you later some resources. There's so much you can do. Just so you have some idea, I do maps in ggplot, I do box plots, I do scatter plots, regression plots. I even did a bingo card once that was randomized for all the values in the thing. So it's just like you can do so much with it. Here is just a very simple example. So this was our basic hour. I think we're kind of on time given that we started a little bit later. But so now we're going to shift to the first intermediate hour. We're not going to have a break necessarily just because it's a lot to go through in a very short time. And there's some cool stuff I want to show you guys. Is everybody okay? Anybody needing to go to the restroom, like really, really important? All right, so let's shift then for, oh, you know what? Sorry, maybe I scared you a little bit. I was a little bit too excited. So what I want to ask you, so as part of this intermediate hour, here's what I want to ask you, how I want to start this. So go on, maybe you already did this, but if you have not, please go to your desktop and create a folder that you can call R Workshop or whatever you want to call it, just something that you know it's about today. So I have mine here. And so we create this folder, go inside this folder, and I want to ask you to create 3 subfolders now. So one is going to be called data, like I have there. One is going to be called notebook, and the last one is going to be called output. So we're going to start getting into some data analysis that are more relatable as far as our studies go, rather than just if you like pineapple or not. And I want to show you how I at least organize my analysis. And I know other people do this way as well, and other people may not do it this way. So I mean, there are many different ways, but I just want to show you how I do, and you can take it if you like, and if you don't, you can just forget about it. But so, you know, this is probably something that if you already have your field studies and you're already analyzing data, like I know in my master's when I started, I had this one folder that said field data. And then I had like, I don't know, 15 Excel files and like some plots and some SAS code and everything kind of like a mess. And, you know, I guess it works. But as you start doing more and more of that, you start realizing that a little bit of organization pays off. So here we're basically going to create these 3 subfolders because we want to, they have a purpose, right? So I want to ask you to go to the email that I sent you and copy that. Well, sorry, hold on just a second. So this script that you were working with, that we were writing along, if you, at least in my R is showing like, if you see, it's showing like a bluish kind of light blue color because it hasn't been saved yet. So if you want to save it, you click on the save button. And in my case, I was already saving that inside of the let's see how I called it, of the notebook folder. And you're going to understand why I called this notebook in a second here. So if you hit save, it's going to ask you where you want to save it. I want you to navigate to that folder. So on your desktop, you have the R Workshop folder. Inside of that, there's a data folder. There's a notebook folder. I want you to save this script inside of that notebook folder. Okay? So after you've done that, I want to ask you to go to the email I sent you with the data and the scripts. And I want you to put that data, the Excel file inside the data folder. And I want you to put the other file, which is a .rmd file, inside of the notebook folder. So I'll give you so I'm not showing you that here, but basically I want you to go to that email and save things in the right place. Okay, so it seems like most of you already got that part done. I just want to show you why we're doing that. So now, you know, it can be just the window of RStudio you have open already. I want you to come here. Sorry, guys, I'm going to have to move this so you can see. So if you look up here on the right-hand corner, there's this project, and right now it's saying none. That's because we are not inside of an RStudio project, and you're going to see what that is in a second. So if you click on that arrow there, it's going to give you some options. So what I want to ask you to do is to click on New Project. And you're going to click Existing Directory. You're going to browse to Desktop, RStudio. So I'm already kind of in there, but so RStudio, and whenever you're seeing this folder, so you enter inside of the main folder, that's the R Workshop, and when you're seeing data, notebook, and output, that's where you want to be, and then hit open. I'm not going to hit, sorry, because I already created mine, but you can go ahead and do. So I want to show you what happens when you create that open. Just going to close this. So because I already created mine, I have this icon here that is the icon for the project. So if I double click on that icon, it's going to take me to where you guys probably what you were seeing when you created the first time, which is it takes you to that specific project. Let me just close here to not give any spoilers about tomorrow. But so what happens is, if you look now, files is going to show you what you're seeing inside that folder. So you have that data, notebook, and output. And if you click on notebook in this case, I have some more stuff that you don't, but you can just click on that intermediate one RMD, and it's going to open up here. So what a project does, it basically focuses your analysis on the folder that you're basically created that project for, right? So before I just want to show you again, I want to open another R window here, or RStudio window that is not in the project. It's not going to do that. Let's see. Well, anyways, you don't have to see it, but what I wanted to show you is basically that when you have that project created, it's going to shift its entire focus to that folder, which is useful because if you have, let's say, if you have EO data and soil test data, I don't know, and whatever else you may have, you have this whole bunch of analysis that they are related to each other because they're in the same, coming from the same field experiment, but they don't directly have to interact with each other. So you can have a project for each one of those variables and not have things mixed up. So when you open, let me just close this. Okay, so now, hopefully, does everybody have this on your, so you created the subfolders, created the project, and then you went to, so here on files, I basically went to notebook and then clicked on intermediate 1B. That's where I want you to be right now. Okay, so now I want to introduce you yet another concept that R has, and that's why I'm calling that folder notebook. So the basic script that we used, it was just an R script, right? So I'm just gonna create a new one. You don't have to create, I just wanna show you. When you come here and you create new, it's gonna give you a whole bunch of options of what you wanna create. So the type of script that we were working the first time was an R script. So you can think of an R script basically as a like a TXT file where you're typing your code and then you're sending that to the console. Magic happens, create a plot on the side, and things are kind of like separated, right? So you have code up here, you have the console running it, and you have outputs going on the side. So that's how I started. I guess most people start programming in R, and I want to show you a different type of script file that's actually called Markdown or Notebook. We're not going to get into the details of the difference, but this one is basically a notebook, and I'll show you why in a second here. Well, you know what? Let's do this. So even though you're seeing this intermediate 1B R notebook file, I want you to come here to the new and click R notebook. It's basically going to open a new R notebook on the side. And I want to show you what it's doing here. So R notebook is basically a way that you can integrate your own text. So you can write stuff that doesn't have to be preceded by a hashtag. And then you have another part of it that's going to be where you run your code. So this here that's starting by this weird sign and ending by the 3 apostrophes there is a chunk. You can think of a chunk basically as the console. And when you run the chunk, it basically creates the output right below it. So you start integrating your own text up here, code, and output, all in the same file. So just to give an idea, I know I never tried this. I think it's hardcore for me at least. But some people actually write papers entirely from R Markdown. They never leave R, and it's something that you can do if you learn the things you have to learn to do it. But just to give an idea. So and if you keep scrolling down, we're going to see there's some text. There's some different colored stuff there that we're going to see what's doing. And it's basically giving you a quick example of what our notebook does. So now I want you to hit this preview button here. That's just to save. We can save it. We could just go into your notebook folder and just save this as example, just quickly there. And then click preview again. So what we have here is that it basically created an automatic HTML report of what it just did. So, I mean, we didn't do anything in this script here because it was already there, but just so you see all of those, like if you go back to the raw code, all of these things here, like the asterisks there, they're always really, they are kind of like a language called latex that lets you tell, like if you want bold or underscript, superscript, you want to add a link to a website, that's kind of like what's doing there. And you may not even need that, but just so you see that these things are out there. So here basically all this text was written up here, and then there was a chunk that had this code that was plot cars, which made this plot, which you can see there, and then the rest of the file is written down there. So this is a really cool way that once you get used to it, you start integrating your own comments, code, and output all in the same file, and you can just work on this, and even if your advisor doesn't use R, you can just send this to him or her, and they're going to be able to follow along what you're doing. And this is HTML, so they don't even have to have R to open it. It opens on your browser. Okay, so you can just close this example one. We're just going to start using our own R Markdown file. So this I already created, and I just sent you with some empty spaces for us to fill up. So, so this first chunk here that you guys already have written there. Oh, just something else that I want to call attention. You may not be seeing this menu on the side here. If you click on that icon there, it's going to show you this menu. And this is something cool about R Markdown as well, is that you can have titles and subtitles. And so let's say if I wanted to have like a 1.1 hierarchy here, I would just use 2 hashtags and then use like 1.1, I don't know, example. And then automatically appears on the side here. So this really helps you to create a flow and you know, sometimes, I mean, hopefully it's not going to be, it's not going to be our example here, but like I have some R scripts or R Markdown files that have like, I don't know, 2,000 rows. That is just that much coding that goes behind everything you're doing. And then how are you going to just be scrolling up and down here? This is going to be forever, right? So this table of contents on the side is really helpful. Okay, so you can just, something cool is that the chunk has a play button, which if you hit it, it's going to run everything that's inside the chunk. And it's going to show you a progress bar on the side. So sometimes, you know, it may be running an analysis that takes a lot of time. It's going to show you the progress of how that's going. So here is just tidyverse being tidyverse. Just because it has so many stuff inside of it, it likes to tell you what's inside of it once you load it. So here we're loading the packages, right? And something maybe I didn't stress is enough is that every time you're going to use a package or functions from a package, you have to load it. It doesn't matter if it's installed already. Every time, so I can close this RStudio now. If I open again, have to load it again. So that's what we're doing here. We're just loading the packages that we're going to need to do what we're going to do here. Okay, so you can come to this second chunk. Oh, and just maybe you're scratching your head like I am now. Like, well, you just said that we don't need to use hashtags. What? You have hashtags there. So if you think about it, if you're outside of the chunk, you can just write normally as you would in Word. But if you're inside the chunk, you got to think of that chunk as like a part of the console. And because it's part of the console, that's what R is going to try to interpret. And so if you want to add comments inside a chunk, they need to have the hashtag. Okay, so let's read our data set. I want to call this soy K. So soy K is going to be the name. I'm going to use that get sign. And if you installed and loaded the read.xl package, which is up here, you're going to be able to see a function called read_xl. Just like that. This function belongs to the read.xl package, which we just loaded above. If you're not seeing the function, if it's not giving you the option to like autocomplete the syntax, is because you don't have that package installed properly. And then you need to ask for somebody's help. But if it worked, if it's showing there, let's just use we can open and close the quotation marks, and then put your cursor in between them and hit tab. So when you do that, it's basically showing you what it is seeing on the folder where the notebook is saved, which is in the notebook folder. So if we want to read in the data, which is in the data folder, we have to get out of the notebook folder, then get in the data folder. To get out of a folder or to go up a level, you type ... and then at least in Macs is /. If you have a PC and that doesn't work, maybe it's a /. You can try some of those. And then once you do that, it already gives you the options of what folders there is in where you got out, right? So now it's showing there is a data, notebook, and output. So I'll click on data, and then it auto-completes for me. I hit tab again. For me, it's showing two. You should only have one. It's the soybean workshop.xlsx. So just click on that. And then, you know what? Before we actually import it, I want to ask you this. So come here on where you have your files. So you have to be on the Files tab. If you hit this button here, it's going to take you to the home folder of the project. So hit there, it's going to bring you here. I want you to go into the data folder, and I want you to click on that XLSX and click View File. We're going to do some changes to it very quickly here. So, so this is what the data set looks like. And oh, does yours already have this R tab or not? Okay, that's great. It should not have. Let me delete mine. I'll just keep mine actually. So what we're going to do, so here we have like a plot column, a treatment column, stage, potassium rate, and then we have some information here on what was measured. Oh, and I just want to say that this data set was provided by Diego here. Thank you, Diego, so much. It's going to be yeah. So it was a very useful data set to show many things we're going to be seeing now. Okay, so people say that data is sacred and you should not change your raw original data ever. That's kind of like what R helps you to do, because we're going to do a whole bunch of manipulation to this data when we bring it into R. But before we do that, I want to ask you to copy just the data part, copy that, and then create a new tab and paste it, because we're going to do some changes before going to R, and I'll tell you why. And then on this new tab that you just created, I want you to rename that to R, and you know why in a second. I'm not going to do it because I already have one, so it's going to be confusing. But that's what I want to ask you to do. Okay, so what are we going to change before we go into R? I know that my masters, I had these Excel files that had merge cells and I don't know, some weird characters that when you import into R, it doesn't really like. It has trouble with it, and it's going to be more difficult for you to handle those variables in the beginning. Let me just increase this so you may see what I'm doing. So what I wanted to do, so this data set here was actually very, very well curated. Diego did a great job. The only one thing that I would tell you to do, that we should change before importing to R is the following. So the I guess philosophy that I use when I'm naming variables that I want to use in R is they have to be short enough that that you don't have to type too much, but still with enough characters for you to know what they mean. And I want, if it's a variable that has, excuse me, that has a unit measurement, I like to have the unit measurement on the variable name. That's just me, but I think it's important, especially because like in this case, we have pounds per acre, but maybe you're gonna report in kilograms per hectare. So let's just make sure that we know what is this unit. So now that you copied that and pasted it on a new tab, let's just rename this K rate here. So I wanna call it K rate underscore pound acre. So this is what I do with all of my data sets. So it's okay for you to have whatever notation you want to have on the sheet that is not coming into R. So now we're preparing this sheet here to go into R, right? And so it has to be R friendly. So we don't want to have extra spaces. We don't want to have special characters. We just want words, letters, underscore. That's it. Okay? So if you look at the other columns, they kind of follow that pattern. So not too much trouble. I just wanted to change this column name to this here. Okay? And just remember also to rename this tab R, uppercase R. And once you do that, you can just close it and save. I'm not going to, but you should. That's the only thing that we changed. So, you know, some people work with CSVs, which is a lot easier to read into R. You don't have to install a special package for that. And if you have large data, CSVs are faster to import. However, that's normally not my case. So I like to have an Excel file where, again, I have one sheet of that Excel file that's all the messiness that I can have. But then I like to at least change some column names, not have merge cells and all that on the tab that I'm actually going to import into R. That's just what I'm showing here, what we're going to do. Okay, so if you did that, if you close your Excel file, you saved it, so you didn't change the name of the file, so you don't have to worry about this path here. But what we're going to do is this read Excel function has an argument that's called sheet. So we're going to say, so you can either give a number. If you give a number, it's going to go by the number of the sheet. And if you give it a name, it's going to go by the name of the sheet. So we're just going to say R. Okay? Because that's how we named it. And then we run it. It should appear up here on your environment now, that object that you just read. And what I'm going to do here is I would just want to print the first rows of it. Just see what's going on. So it's a little bit difficult to look at that in here. So what I want to do is actually show you how to like kind of visualize after importing to R, to visualize how R interpreted your data frame. So if you come on your environment here, maybe yours is a little bit different than mine, I don't know. But hopefully you're going to see a symbol, either a symbol of a table that you can click that's going to open your data frame, or your data frame itself may have a link, active link that you can click on it, and it's going to open this window here showing you the data frame. And if not, a last resort that I can show you, instead of clicking, there is a function called view with uppercase V, that as long as you say the object name and you run it, it's going to give you the same place. It's going to get you to the same place. Let me just show the function again. You could have clicked on the side. Maybe you don't have the same view as I do because I think I changed my settings, but I just want you to kind of like be able to see, and it's important to look at it after it's been imported into R, because you have to see how R interpreted those variables. Okay. Yes.
And the problem that in my computer we use commas, not points.
I don't know.
Because it was automatic, like my Excel opened with commas, not points.
But did it import into R?
Not now. But everything fine until I did this.
So I think maybe it could, you have a PC, right?
Yeah.
It could be, I know that depending on the system, you may have to, well, Let's see if I can just get here.
Right now.
Okay, okay. Let's just see. Oh, I think you're. Okay, you're missing a quotation mark there.
What?
You're missing a quotation mark
Ah,
right there.
this?
No, like, yeah. No, try around that. Yeah, there you go. You just like you open quotation, but you forgot to close it, so it was getting confused. Okay, so that's just. Can we? I mean, how are you guys? Like, if you're having an issue, please raise your hand just so we have some idea. I know there's some people helping here. Okay. Sorry.
On that part of the copy showed the folders that we created in there, the subfolders of how basically how you open that up, how you put that in there. I was trying to do another way, copy the path and get it in there. I don't know. I can't get it to go when I copy the path out of the folder.
So can I just try to, so that's kind of like what's useful of the project as well, is that you don't have to worry about copying and pasting paths because it already kind of knows where you are. Yeah, so you don't have anything in here. So let's do, let's just go back. Oh, well, you don't have the project too. Yeah, I think you got lost there. Do you have the project created?
No, I got lost.
Okay. Okay, I think, well, you have some projects. Okay, let's just do this. We can just close this for now. We don't have to worry about saving that. Yeah, that's kind of like, it's the important part of, oh, sorry, I don't want to do that. Okay, so your data here, right? So copy your data into the data folder. And then these are the project files, I believe, right? And then let's see, a notebook. No, so this would be, it's just
I hit the save button and then do anything.
like control delete, or how do you delete that? Nope, shift. Yeah. Okay. I'm just going to delete those, and yeah, we can just delete these two. Delete. Okay, now we can delete this one too. So can you just like go to your email and then copy that intermediate file to inside that notebook? Yeah. And then while I do that, I'll help some of you. So you had a similar problem?
Yeah.
Okay. I'll come back to you guys. Excuse me, I'm trying to get to this guy here.
So I could bring the data here, just like this one. But I missed the next part next to this.
Well, I mean, so you just add a comma there, like after the quotation mark. Like you go after it, add a comma, and then there's if you hit tab, you're gonna see an argument. Oh, well, sorry, that's not what we want. So there is an argument called sheet. I'm just gonna type for you, and then you wanna open quotation marks and say R inside of it.
Okay.
Yeah. So now try to run that, and let's see if that happens. So let's let me show you a shortcut. So if you just push Control Enter, yep. Okay, it's giving you a problem. Let's see why.
You did something on the Excel file, yes?
Yes.
I didn't do that part.
Okay, I can do that for you, just so we go quickly. Okay.
That this one, I mean,
No, I mean Here it is. I basically just changed that. Yeah, so we have everything else, right? Okay, so now, which one is it? This one? Okay. So I think it's basically, because if you, okay, so, I mean, we can see this. I want to close, and let me do something here for you. So we actually want to have notebook. Oh, here it is. Okay. Let's just move this here. And then, yeah, so I asked you guys to save in that notebook. And then once you go inside there, sorry, I'm not getting this. So we come here, notebook, we open the RMD. So we load these packages, and then this should work. Well, we should like get outside of the folder. Yeah, let me just. So we get outside data. So this should work. Yeah. 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 Did it work for you guys? Sorry, let me just come here. What's that?
You wanted that in the data folder, right?
Yeah, so the data folder, and then. And then, oh, I'm sorry, I was deleting those. I thought, because on Mac, the R symbol is for projects, and I thought it was a project. Sorry,
yeah,
it was an
actual. I don't know if we
accidentally
delete basic information. That's okay.
No, that's okay. Yeah, we can always restart. Okay, so now so we have to create a project, right? So project, new project.
I got lost in this part.
You don't have to, I mean, if it's just stuff from today, you don't have to save. Yeah. You can go to existing directory.
Okay, this is where I got lost.
Yeah, and then
that's that folder I have out there on the desktop.
Okay, so all the data, other things are inside this folder. Okay, perfect. So you can just create a project. Okay, and now, so you see how now it's showing that directory specifically?
Yes.
So now you can just click on notebook, and yeah, I think
I put it in data.
You can click here to come back to the main directory, like the blue R. Sorry, the R symbol there takes you to the home directory. I could just like right click or left click it, like normal click.
Okay, and then go back.
Can I just like? You can just click there, and then go on your notebook. Where is it?
I have it in the data one. Do we want it in the?
I mean, if you just want to go back there, I mean, you know,
How did you do this?
Ideally, yeah, just this there. So data, and then intermediate. Yeah, you can just open it. And so in your case, because your script is actually inside the data folder, the path that you're gonna have, so you can just come here and kind of, you know, let me change there so people can see. Yes. How is anyone else having trouble with this? Like, this is the time for us to kind of, because this is important. You have to have the data before we do anything else. Okay, I'll just show the guys how. Just gonna help you guys. Okay. So you can just run this chunk here by playing the play sign. It's just gonna load those packages, and that's all right. It's just some warnings that tidyverse gives. So we can come to the other chunk here now. So you can kind of like copy and paste what I did up there. So right next to soy K, you use the Yeah. And then the function is called read_Excel. It should, it should, like if you start typing, it will show there. Now we open quotation marks, so like open and close. And when your cursor is in between them, you hit tab. And that shows you your current directory.
There we go.
Yeah. So right now, you don't have to do what I did because I had saved my script under notebook. So I had to get outside of notebook and inside a data folder. In your case, because you have them together, you didn't have to do this, just so you know.
Okay.
And then now,
Now I just finished this.
we just specify the sheet name in this case. And then, did it work for you?
I got this, or what were we saying? You gotta hit tab?
Yeah.
Oh, okay.
Yeah. You can do. Thank you. All right, guys. I think everybody kind of got to this point here. If you did not, really raise your hand. We'll stop for somebody can help you, because if you don't have the data in, you're not going to do anything else. So you need the data in R. Everybody's good? Okay. So just so you know, we're going to be running late. So we can either, so now it's 6:22. We had scheduled to finish at 6:30. Given that we started later at 6:45, we can either go until 6:45 and see how long into this we get, and then start tomorrow, which means that we're going to start late. We're going to be seeing stuff today. Tomorrow is going to put everything behind, or we can go a little bit later today and see everything that we have today and start fresh tomorrow. I know that you probably have your own lives in doing stuff after our workshop, so it's really your call. Maybe we can kind of vote, I guess. If the majority wants to stay, we can stay. I'm fine with that. If you want to stop at 6:45 and go home and just going to have everything delayed, that's fine as well. Do we want to just like whoever wants to stay till we finish, raise your hand. Okay. And I'm assuming the others don't want to stay. So if you can raise your hand if you don't want to stay. Okay. And if you don't, sorry, this is just, if you don't know, then I don't know what to say. Well, I know, I guess more people raise their hand to stay than not. I guess we can try. I mean, we're not going to stay here till 10. We can try till 7:15 or something and see where it gets us. It's just that the more people we have in the workshop, the more chances there are for stuff to go wrong and then things get delayed. That's how it is. Well, we'll keep going. Like if it gets to 6:30 and you need to leave, you're welcome to. I'm going to share all the finalized scripts by the end of tonight or tomorrow morning, perhaps. So, you're not going to be missing the code itself. Once I send to you, it's going to be reproducible. So you're going to have my data and my code. You can just rerun everything. So you don't have to worry about that. And this is being recorded, right? Right, Luciana? This is being recorded, so you can, yeah. So, I guess we'll just stay. If you can't stay, you're welcome to go. It's going to be recorded. You're going to have the code afterwards. It's going to be fine. All right, let's get moving then. So we all imported this data. We call soy_k. If we just take a look at it, I actually want to use this view here just so we see on the side. And I just want to tell you what this is. So we have here a column that's called plot, one that's called treatment that actually has a treatment number. What this study here, well, I'll just tell you about the columns and then we talk about the study. There's a stage, and this stage is just one value. So it's not really giving us much information. Then we have different potassium rates in pounds per acre. So we have 0, 50, 100, and 150. And then we have 4 columns here that were measurements. So what these columns here are is the following. Each one of these columns here, starting A1.kpct, it's the percentage of potassium on soybean leaves. Is that right, Diego? Soybean leaves?
No, the whole plant. Yeah.
Whole plant. Okay, whole plant potassium concentration on soybean plants. And the A1, O2, S1, W1 are different locations. So imagine that that this is your study. You have 4 locations. This is randomized complete block design. And you had 4 locations, and you had a column where you enter the information for each one of those locations. This is not how Diego gave me the data set. I had to make this look like this because he gave me actually in a pretty good shape that would not work if I wanted to show some of the stuff I'm going to show you. So I had to make it look bad actually. But this is, this could happen to you, right? Like to any of us, I guess. Like you can go to the field and collect stuff on this way, and then you want to analyze. So this is actually, it has a long ways to be in a format that we can actually analyze. And I'll tell you what I mean by that. So I just have some description here of what this study is. And so in this chunk here, that's called glimpse, I just want to use the function glimpse. And you can just call the data set name, so soyk, and you can run it. So what glimpse does is it gives you kind of like a summary of what's going on. It tells you the column names. It tells you how R is reading those column names. So for example, plot is being read as double, which is basically a numerical that can have a fraction, like a numerical continuous variable. We see that stage is being read as a character because it's within quotation marks. So it sees that as a word. Everything else is numerical here. And I wanted to show you this because this is something that I always check for reasons that you're going to see maybe tomorrow. Okay, so let's just go ahead and use that summary function that you already learned on this data set again. So everything that was numerical, that was considered as double by R is going to give us that range. So minimum, maximum, median, and all that. And whatever was a character is going to give just like how many times things happen of a given type, of a given character in that data set. So we see here that mostly everything is being seen as double, as numerical. And for example, plot and, well, I guess in this case, plot and treatment columns don't really have to be seen as numerical if you think of it. Well, like you're not going to have plot 102.5, right? It's 101, 102. So we're going to look into that more closely later as well. Okay, so I want to show you guys some data wrangling functions that I hope are going to be lifesavers for your projects in your analysis. So let me ask you this. When you have to do any type of data manipulation, let's say you want to create a new column, or maybe in this case here, like we have 4 columns that have information on sites. What if I wanted to take each one of those 4 columns and put one below the other? Or maybe you wanted to filter a data set, or different manipulations you do on a data set. If you have not been doing this in R, how do you do? It's okay. Excel mostly, probably. Excel. Has anybody here used pivot tables in Excel? Some people did. So what I'm going to show you here is basically some functions that it's kind of like pivot tables on steroids. Like they do a lot more efficiently, a lot less prone to error, and really helpful. All right. So the first one here, I want you to create an object called soyk_1. Use that get sign. And we're going to use the function filter. So let's say I wanted to filter. So we saw that there's a column that's potassium rate that we have 0, 50, 100, 150 pounds per acre. Let's say I just want to filter the 0, the rate 0, right? So I say filter. The first thing I have to say is a data set name. So that's soyk, if you recall. I add a comma. I'm going to add an enter here. It's not needed, but I just want to add to make it more clear what we're doing. And then if we just, I want to show you a function that's going to be very useful throughout this part of the workshop. There's a function called names. And if you use names and use a data frame inside of it, it's going to give you the column names of your columns. So we're going to use a lot of these names now. So that's why I want to show you a quick way for you to retrieve those names, copy and paste. So use the function names. So what we want to do then, imagine that we want to subset this data frame by potassium rate that equals to 0 only. So I just copied and pasted the name of the column. I'm going to use equal, so 2 equal signs, 0. Okay? So we run that. And then I want you to copy the name of this object that we just created and paste down here and run it. So it prints down here the result. So you can see that hopefully it worked on yours as well. On mine here is just showing 4 rows of the entire data set, and those were the ones where the potassium rate was 0. So we filtered the data set by this condition. So if you remember, just like previously when I was showing you how to subset using the brackets and that notation, that is really like when you start learning R, that's how you kind of learn how to subset things. But then once you start learning, so this is called data wrangling, and all these functions here that I'm going to be using, they are functions from packages from the tidyverse. And once you learn these functions, I mean, you never really subset with the brackets anymore. It's just kind of like we go step by step and you see the progress, but you can really start using these functions if you want. Okay? All right. So we just filtered it and we saved on the object called soik_1. So now let's use the function mutate. So mutate has a funny name to it, but what it really is it's going to create a new column that you're going to say what that column is, and we're going to see that right now. So let's call this second object soik_2, and you have these things here. For right now, you can just enter and put them like below. You kind of ignore them, those numbers. We're gonna use them in a second here, but for right now, we don't need them. So let's use that assign symbol, use the mutate function. So again, this mutate function, the first argument it needs is the data frame that's gonna start with. So that's the soik. So not soik_1, just soik. Then we add a comma. I wanna hit enter. So what I wanna do here, and what the objective of this part, this chunk here, is basically to transform that pounds per acre rate of potassium from English to international units. So let's say you want to publish your work somewhere, it's going to have to be in international units. So I'm going to create a column, I'll call it krate_kilograms per hectare. Okay, so I say equals to, and then this is going to be basically the krate LBAC that we already have, and then you can just copy and paste these numbers right next to that, because that's the transformation that you get from pounds per acre to kilograms per hectare. Okay, so if we run that, and then we again copy and paste the soik_2 and print it, it's going to show us the entire data set, and if you come on the side here, it has an arrow that's going to show you the other columns, and we can see that now we have a new column on the data frame that is the potassium rate in kilograms per hectare. So one thing that you see here is that it actually created that column, but it has like 5 digits after 0. Like you don't really need that. We just need like 0, 56. You know, we don't have any numbers after the 0. So what I want to show you here is right after the 6 that we used to transform, you add a comma, hit enter, and you can just copy and paste this krate kilograms per hectare again, say equals. We're going to use a function called round that we say what is the column name we want to round, comma, and how many digits. I want 0 digits for that. So this is how it's going to look like. So we're basically, so you kind of see how the first time that we created the krate kilograms per hectare, we are creating a new column, and then the second row there, we're actually overriding that same column just with fewer digits. So if I run that, print soik_2, and go to the end of it using the arrow, you see that now we have a numerical variable kilogram potassium rate in kilograms per hectare, and now it's just the full number.
Would it still work if we write on the same line?
It should, yeah. As long as you like get your parentheses. I mean, you have to have your parentheses right regardless. I'm just hitting enter to be more to be easier for us to read the code. But yes, it should work. Okay, I think we're going to move on. So now what happened is, I'm just going to print this again. Well, it's right here so you can kind of see it. The only treatment identification we have in this data frame is 1, 2, 4, 5. That doesn't really tell us much, right? We don't know what those numbers are. So I want to create a new column that's going to be based on the treatment number column that we're going to give the name of those treatments. So we can come down here to the case when chunk. I want to call this soy K _ 3. We're going to use the mutate function again. So mutate, open parentheses. As the data frame that we will start this mutate with is going to be the soy K _ 2. So soy K _ 2 is what we're starting with. Then you can add a comma and hit enter. And now I want to create a column that I'm going to call rep for replicate or repetition. So rep equals. So now think of this. I want to create a function that's called rep. Oh, you know what? I just realized something actually. What we are doing, let me take a step back here. So I said that we were going to create the treatment names, but we actually have treatment names, which is the rate, right? Sorry, what I meant is there is no rep or block column here, right? So we don't really know what's the rep number. However, we know that all the plot numbers that start with 100 are block 1, 200 is block 2, and so on. So we're going to use that information to create the rep column. So right after that rep equals, I want you to use the function that's called case _ when. And you can just hit enter. So what we're going to do is the following. We know that plot numbers go from 101 to, I don't know, 110. That's the first rep, and so on. So let's create a logic here that we want to express to the computer to how we're creating this column. So if plot number is greater than 100, then is rep equals to 1. Well, that's not going to be great because everything is greater than 100, right? 100 to hundreds, so that's not going to work. We have to put an upper boundary on this decision. So if plot is greater than 100 and plot is fewer than 200, then, and you say then here in this case with a tilde, 1. So we're saying if this condition here applies, this new column that we're calling rep is going to receive the value 1. So I add a comma there, hit enter again. I'm just going to copy and paste this exact same thing on the row below it. And just change now, if it's greater than 200 and less than 300, then it is 2. If it is greater than 300 and less than 400, then it is 3. And the last one, because we only have 4 blocks in this case, and plot number doesn't go above 400s, then we say if plot is greater than 400, then 4. And then I think that should work. Let's try to run. Yeah, it worked for me. So I'm just going to give you some time to make sure that you got your commas right, that you got your parentheses right as well, because this can be tricky and it's usually the cause of problems. But now if I just print the soy K _ 3 and we go to the end of it, we're going to see that now we have a rep column that is, so 1, 2, 3, 4. If we go to we check the plot is 100s, 200s, 300s, 400s. So it did the job. So I know that like when I was using Excel, if I wanted to do something like this, I would maybe use like an if else statement saying if else, and then you open bracket and say if plot number is this condition, comma, then do this, otherwise another if else, and so on. So this is kind of the logic behind what we're doing here. Just going to give you 30 seconds more just to catch up, and then we'll move on. Okay. Can I go ahead? All right, I don't hear any no, so I'm going to go ahead. So think about this way. We have 4 locations. It's an RCBD. So we need to have a wrap column, which we already created. We need to have a column that says location or site or something like that, which we don't have yet, right? And I want to show you how, at least slowly, how we're going to get there. So I'm going to ask to view this data set here just so you can see better. And I'm going to ask you this. Okay, so this is the data set. I want you to look at this and think about it and tell me, where is the location information on this data frame? The column name, right? Yes, yes. So maybe you missed when I said the first time, but so A1, O2, S1, W1 are the locations. So they're on the column names. How are we going to get this into a column that says location and then gives each one of them in this order, in the order that they have to be? So let's start doing that. Start working on that. So there's a function that's called gather. I want you to create a new object called soyk_4 gets, and then open the write up the gather function. And now we're going to reuse the data frame that we created above. So we're going to reuse the soyk_3 as the input of this formula and hit enter. So this is how it's going to work. Let me just open this again and show you. So what we have to do is we're going to take these 4 columns. So the A1, K percentage, O2, S1, W1. We're going to take those columns, and if you think about it, the values that they have in the column, like in the body of the table, are actually the percent of potassium, right? So we're going to take them and put one inside of the other. And the potassium numbers, we're going to call it, I don't know, potassium something. However, when we use the gather function, it wants us to create another column that's going to be where the column names are going to be repeated, right? So think that, so if we think of A1, the first column there, A1. So it's going to take those numbers, it's going to call like potassium, and then it's going to take the A1.kpct, and it's going to repeat that in another column that doesn't exist yet, all the way through for those values. And then it's going to do the same for the next column, the next one. It's kind of abstract, but we're going to do it, and then you're going to see how it's going to work. So with the function gather, so after you say what data frame you're using, you have to tell it what are the new column names that you don't have yet that you want to put the titles and the values of the table. So the titles I want to call like location.k. And then comma, the values I want to call K_PCT for percentage. And then I want to give a comma again, hit enter, And now I want to tell it, you can either tell what columns you want together or what columns you don't want together. In our case, I will tell it which ones we want together. So I want to show you again, you can use the names function of the soyk_3. It's going to give you those names. I want you to copy and paste without the apostrophes, the A1, O2, S1, and W1. Okay, so it should look like this. We're going to give you here 15 seconds to do this. Okay, now I'm going to run this. And I want to print the soyk_4 here, just so we see what's going on. You know what? I'm going to actually ask to view it so you guys can see the entire. Okay, so what happened now? So it took all those values that were from A1 and then placed them under K_PCT and repeated the A1 information here. And then ended right here. And then it did the same for the O2, S1, and W1. So now we have a column that has some information of location. But we're still going to work it out. I'm going to show you again the code just so if you're trying to get it right. Here's the code again. So who is having issues? Please raise a hand. There's a person there, person here. Who else didn't get to this point? Who was it here that had issues? Oh, Joel, you had issues? Okay. You get it? Okay. Does anybody have issues? Because we have to have this to move, like, you have to have it to move on. Otherwise, it's not going to, the other thing's not going to work. Okay. I'm going to continue just for sake of time. All right. So, excuse me. So this is what we have now. So we have a column that is saying A1 dot something. The something we don't really care. The A1 is the location that we're after. And then another one that is the percentage of potassium. So now, you know, we could, I mean, right, we have the location there, but it has this dot kpct extra that you're not going to really publish in Nature, right? So we want to remove this from this name. The cool thing is that when this data set was created, we thought about having this unique separator to all the column names. And then we can use that information, that dot, to say whatever is on the left side of the dot is site, is the location. Whatever is on the right side is something else we don't really care about. So let's use that information and separate those two things. So come to the next chunk that's called separate. I want you to call this soyk_5. Use the get sign. The function is called separate. We need to use the input data frame is the one that we just created above. So it's the soyk_4, comma, hit enter. And then we want to say what is the column that we want to separate into two. So if you look again, that column name is location.k. So I'm just going to write here location.k. In my case, k was uppercase, so that makes a difference. And then I'm going to add another comma, hit another enter, and then this function separate has an argument called into. So we're going to say what are the new two columns you want it to create that you're separating that one column into two. So let's say into equals. We're going to use the C function to concatenate. And right now we're gonna have to use the quotation marks to say two names for this. So I want to call the first one location, and then I get outside of the quotation marks, use comma, quotation marks again, and you're gonna call it K name. Okay, just gonna give you a second to catch up. So I run this, and now I want to just print this below to see what happened. Well, let's just actually view it, just so we can see up here. So now we have one column that's called location, and it knew that there was that dot on every entry of the previous column. And again, everything to the left of the dot became location, everything to the right became K name. So K name has KPCT all the way down. We really don't even need it. We can just discard this column now. But the good thing is we have this location name that now is unique. So remember that we went from this location name being on the column title, and then we gathered it, and then we separated it. So it's like we're doing all these things to the data frame that if you're going to do manually, and this is something that comes down to reproducibility again. If you're going to do this manually, imagine how easily it is for you to just mess up and just do copy and paste something in the wrong place, and using functions is really make sure that you're not making those human mistakes. Okay, so now let's use the select function. So if you remember, when the first function we used was filter. So filter was working on the rows. So we wanted only rows that where potassium rate was 0, right? Now select does something similar, but to the columns. So now let's say we want to tell it what columns we want to keep. And it's really not super useful, like for an analysis standpoint, is more to clean things up. Because if you look at our data set here, soy K, we have like, now that we already created the rep, we don't need the treatment column anymore, or we don't need the plot, we don't really need a treatment, we don't need stage because the same value across or all the way through. We don't, I mean, if we're gonna do this for international units, we don't need the pound per acre anymore. We definitely don't need K name. So there's only a handful of variables that we really need to continue. If we want to clean this up to make things easier for us, we can do that. So let's use here, let's call this soy K _6. And sorry, this is under the select chunk. Use the get sign. And just this is a very important tip for you to keep in mind. So the name of function select is a name that many packages use. And usually when I'm writing this type of data wrangling functions and I get an error, it's usually because I type select and it's trying to use a select from a different package, not from dplyr, which is the original package that we want to use it from. So when that happens, you can explicitly say the package name that you want that function to come from. And to do that, so the package that this is from is called dplyr, like this. So you can use package name, : and select. So it makes sure that that select function is coming from that package, is forcing it to come from it. And again, this is the only place where I'm showing you is because this select function appears in many packages, and sometimes you don't even think of it, and you're using it from a different packaging, it doesn't work. And so that's usually the reason why. Okay, so for the select, I just want to use here the soy K _5 as the starting data set, comma, enter, and then I want to tell it only the column names I want to keep, okay? So let's use the names function again, just to get the names of that. So we do not need plot, do not need treatment, don't need stage, don't need K rate, pounds per acre. So we're going to need K rate in kilograms per hectare, rep, location, and K percentage. So those are the ones we're going to need. I'm just going to start typing on the order that makes sense when you think of it. So it's going to be location, maybe the first one is the higher hierarchy of this, right? And then rep, and then K rate, kilograms per hectare, and then K _percentage. So if I run this, and now I printed, I see that now my data set is clean. It's just what I need, the columns I need, all the information I need to run an analysis or even just to plot stuff is right there. Okay, so this again, sorry, this was the code that created that. Everybody good? Just so you know, we're almost done. I think that probably will be done at that 7:15 threshold. Just a heads up if you're scratching your head, worrying that we're going to be here till 10. It's almost there. Okay, is everybody here, like at this step? Can I move on? All right. So, this data set here looks just what we need to start doing analysis and plots that would be more informative. However, before we get to do some very simple plots with this, I want to show you two more functions that are really powerful from dplyr in data wrangling. So let's say we have this data set now that I have location, rep, the rate of potassium, and the percentage of potassium on the whole plant. Let's say I wanted to calculate the mean potassium percentage across, let's see what I did here just to keep consistent, across locations. So I want to average over locations. I want to end up with a data frame that has 4 rows, 1 for each location, and the average potassium concentration at that location. Okay, I'm going to show you how to do that right now. So the first function here we're going to use is group by. So I want to call soy k_7 gets, and then I'm going to use the group by function. So we're going to say what's the starting data set is the soy k_6 with the one that we just created above, comma, and then I want to say what is the group, the variable that I wanted to create groups with. So as I told you, I want the average per location. Don't care about treatment. I want to average over reps just by location, okay? So we say the data set name, that's the starting, and then the variable name that I want to average over. Well, I mean, it doesn't have to be average. It can be minimum, maximum, median, anything. Anything you can calculate over a given amount of data, you can do here. I'm just saying average, but that's the most common one, I guess, that we use. So I want to run this. Okay, I ran it. And I'm going to print this, soy k_7. And, well, it didn't do anything, right? I mean, we still have the same 64 rows, all the reps, all the rates. I mean, it didn't do anything yet because we didn't tell it to do anything yet. We just told it to create groups. And the way that dplyr does in the back end is the following. Let me show you this. So we're starting with soy k6, right? I want to ask for the class of soy k6. So we get what object type R thinks it is. So it's a table data frame, table data.frame. This is what soy k is, which was before we did the group by. Now I want to do the same thing for soy k7. There is a slight difference there. There is this part that says group df. So behind the scenes, after you apply group by, dplyr, that data frame knows it has a grouping intrinsic. But because you haven't told it yet what to do with that grouping, it just hasn't done anything. So now, and that's where summarize comes into play. So usually group by and summarize they work together. You create the group first, and then you summarize over that group. So we're going to create here another object called soy k_8. We're going to use the get sign and then use the function summarize. Excuse me. So for this function, we want to start with the soy k underscore 7, which is the grouped data frame that we just created. And then I want to call this mean k underscore %, just to follow the idea that we're having here with the naming conventions. Then I say equal. I use the function mean. I open parentheses, and I'm going to tell inside of this function the column name that I wanted to average over. So that's going to be the k underscore %. Okay, so we run that. And if I print soy k underscore 8, there it is. So now we actually use that behind the scenes grouping that we first created and calculated this variable that we asked it to create. Let's say if we wanted, I'm going to change here. You don't have to change on yours, but if I wanted the minimum, there's a function called min. Sorry. So if I run it, even though here's still calling min just because I didn't change the name up there, but now it's the minimum value for each one of the locations. There's one called max. There's one called median. So there's a whole bunch of functions that you can apply with summarize after you have done a group by. I'll just keep the mean here. Whew. Okay. So one last thing here. Have you guys heard about pipes? And not the ones that carry water or something else, but in programming, have you heard about pipes? So a pipe, basically, you know what? I guess I'll just get started with the pipes here, and I'll show you what they do. It's easier to show than to say. So we're going to pipe it all together in a way that you saw that we, at some point, I think it was after soy K3, we started always using the data frame that we ended on the previous step. So soy K3, we started with soy K2, soy K4, soy K3, So every time after starting at soy K3, we're always creating something and using that as the input of the next function. Then doing something, using that again on the next function, and so on, all the way through soy K7. So if you think about it, we actually created and saved 5 different objects in between. And the middle ones, we don't even care. We just really want that last one that after the select. That's really the one that we're now going to use for analysis. So there is a way that we don't really have to create all these in-between objects and basically just pipe our results from one function to the next and never having to save it to file, but just channeling the output of one function as the input of the next, and so on. So I want to show you now how to create a pipe workflow to do all this, and it's going to be a lot easier than what you may be thinking it sounds like. So I want to call this soy k underscore w, and that's the convention I follow. Many people have different conventions. Every time I get my data set, every analysis, right? You bring your raw data set, you do a whole bunch of stuff to it, and the final form of it that you're actually going to use for plots and analysis, I add the underscore w for saying wrangled. This is the wrangled form of my data frame that now I'm going to use to do everything I want to do with it. So I want to call this soy k underscore w, and we're starting with soy k. So you may not even remember soy k. It was the first one we brought in up there. So let's start with this, and let's use the pipe. What is the pipe? The pipe is the symbol here that's percentage greater than percentage. This is the pipe. Then the convention is after you type the pipe, you hit enter, and you go to a new line, and then you say what's going to happen. So what I wanted to do is to go all the way up to, let's see, to this here. Yes, so to the mutate chunk where we have soy K2. I want you to basically copy the mutate part only. So do not copy that. Just after the mutate, copy that. Let's go all the way down to the piping it all together. I want to get here, hit enter, and I paste. There's one thing only we have to edit here, is that when we were using this mutate function up there, we had to say what was the starting data set, which was soy k. Now the pipe is doing that for us, so we do not need to do that. What the pipe does is it takes what's on its left, and it says that this is the input of the function that's on its right, or in this case, in the next row. So I'm just gonna delete this soy k part and leave it just like that. So we can run this, and if we print soy k underscore w, it should be exactly what soy k2 was up there, which basically this extra column here with the k rate in kilograms per hectare, but still has all that messiness that we had before, because we haven't incorporated into the pipe yet the other steps. Okay, so now I'm gonna just keep this pipe flow. I'm gonna add the pipe after the end here of the parentheses of the mutate, hit enter, and I'm gonna go up to the case when. I'm gonna copy again, leaving that soy underscore k get sign behind, just copying the mutate, and then going to the piping it all together chunk. So remember that I added a pipe here in the end of the first mutate, hit enter, paste the second mutate. So now the same thing is we just have to delete the data frame specification from when we copied it, because now the pipe is doing that for us. We don't have to tell it what's the input data frame anymore if you're using the pipe. So I'm just gonna keep going. I think now you kind of got what I'm doing. I'm just gonna do it, and I can kind of tell you, like narrating what I'm doing, but this is what we're gonna do. We're just gonna add a pipe, hit enter, go all the way up to the next step. In this case, the gather. Gonna copy the gather, go to piping all together again, get after the pipe, hit enter, paste it, and delete the data frame specification. That's what I'm gonna do all the way to the select. If you wanna do that as well, you're welcome to. So after the gather is the separate, copy the separate, delete the data frame specification, add another pipe to the end, and now is the last one, which is the select. And once I'm done with it, I'll let you see what I've been doing. Just so you can try to match. But what I did is basically that. I just copied and pasted, adding a pipe to the end, and removing the data, the first data frame that the function had when we were doing up there. So this is what's gonna look like in the end. Well, is that making sense? Sort of. Yeah, it's kind of complicated. I mean, this is kind of the tough part of this workshop is that, you know, I want to show a little bit of everything that gets you guys going. And maybe it's not going to make too much sense right now because it's really something I learned over a long period of time, definitely not in 2 hours. But it's just to get you understanding the idea behind it. Is anyone still trying to copy and paste, following with me? I can wait. Good? Ready? Well, we can wait for anyone else needing help with the pipes? So again, what the pipe is doing is basically taking whatever is happening as the output on its right, on its left, and using that as the input on whatever it is on its right. So it's just channeling the results of each function to the next. And if you run this, I think it worked. Let me try to print this. Yeah, so it did work. So there's a cool way of checking to actually see. So if you think of it, this soy KW should be exactly the same as soy K6, right? Well, there should not be any difference. So, but what I was going to say is we can actually check for that. if they actually got to the same result, which they should get to the same result if we copied all the functions that we did in the same order. So there's a function called identical, and you can just give it any number of objects for it to check if they're 100% exactly the same. I'm just going to say soy k underscore 6 and soy k underscore w. True. So if there is at least one number that's not the same between those two, it's going to give a false. So this, to give it true, has to be 100% the same. And they were. So I just wanted to show you guys that, like for example, I use these functions every single day on data analysis, but I use in pipes like this. And maybe in the beginning it's difficult to think on the pipe flow, but once you get the hang of it, it's really helpful and then that becomes the way you think about analysis. You kind of like think of the computer way because it makes so much sense. And just a tip, like if you start using this and you start using pipes and you get something wrong, usually you can try to troubleshoot by just adding a hashtag in front of one of the pipes and running whatever is before it. Because when you add the hashtag, it's going to only run up until here in this case. And then I can check. Okay, it's doing what I want. And then you can just delete this hashtag, go to the next pipe, and block that. And then run again. So that way you're kind of like going step by step, checking what's going on. That helps you to troubleshoot and see if you have any mistake in your code. That's how you can more easily find what's wrong with it. Okay. Whew. Now the last chunk. And this is going to be important because we're going to use this tomorrow. Okay.
Are you planning to continue on the exercise also?
No. This is it. Yeah, the exercise I'll let you guys do at home if you want. Yeah. No. Okay. So, all right. So if you think of it, the soy k underscore w, which is the same as the underscore 6. Wait. Oh. You see, like I added the hashtag and ran it, and then I removed it, but I didn't run it again. So I just have to rerun again, and now the soy k is going to be equal to the soy 6. So this data set here is what we're going to start tomorrow. So tomorrow we're going to start plotting and running ANOVAs, randomized complete block design ANOVAs, using this data set that we wrangled. And this is basically, and normally what is the normal workflow, right? You bring a data set, it's kind of messy, you wrangle it to a point where it has everything you need for plotting and analysis, and that's what you do. So this is basically like my personal workflow that I'm showing you guys just in 4 hours instead of a lot less, hopefully. Okay, so let's export this. Let's save this data set to file, okay? So there's a function, if you don't have to look, I'm just gonna show you. This open XLSX has a function to write an Excel file. So I just wanna come all the way back down here. So the function is write.xlsx. So you say what's the object name that has whatever you want to save to an Excel file. In our case, it's soyok underscore w. And then you open quotation marks because you're inside that project. And so maybe I forgot to tell this, like, why do I like projects? Like RStudio projects is because it centers your view of the analysis to that folder. So when we were reading the data, if you place the data into the data folder and the script into the notebook folder, this worked for you where you just put your cursor in between the quotation marks, you hit tab, and then it gives you the path without you having to go and copy path and paste path. It can be a little bit more complex. So again, I put my cursor in between the quotation marks and hit tab, and it's showing me where the script is saved, which is inside the notebook folder. So now to go up a level, I use ... and use the / for max, and it's showing me the main folder of the project. So let's save this as a data. Normally, everything I'm creating new, I save on the output folder. But in this case, because we're actually going to use this data as data, let's just save on the data folder again. So data, and then if you hit tab, you should only see, as of now, the soybean workshop.xlsx. If you want, you can just hit it, but to not overwrite on the raw data, let's just give it a new name. Like let's just add like process to the end of it, or whatever you want to call it, just so you differentiate and don't overwrite your raw data. So you run this, and oh, just a quick tip here. So if you are in the project and you come to the files, you have to be in the Files tab. The Files tab has this icon here, which if you hit it, is going to take you to the main directory of the project. Once again, I'm going to go into the data, and if I want to go back to the home directory of my project, I just hit that R project icon, and it takes me there. So now, if you have already saved this data set in a new Excel file inside the data folder, you should be able to come to your main folder, go on data, and it should be there. Just going to open mine here. So you should have the exact same thing as this. If you were following along, did you get to this point? Could you export the data frame? So I'm going to send you the full code of tonight in case you got lost, in case something didn't work. And then if you want to go through it, just be aware that tomorrow we're gonna start importing this data set, the process data set. So if you don't get the process data set, you're not going to be able to follow along. And as you saw today, we go really fast. So if you blink, you miss it. So you have to be ready. So I'm going to share the code. If you were not able to create the process, we have try to run the code that I'll send you. If it doesn't work, let me know. We have tomorrow until 4 p.m. to figure this out if it's not working for you. My office is here in Throckmorton. You're welcome to stop by. You're welcome to ask questions. Just make sure you have this data set. I'm not planning to send it just because I don't want to cheat. I want you guys to actually be able to create this as part of the exercise. And then, so this is basically how we ended today. I just have an exercise here. If you're really overachiever, it doesn't have to be today. If you want to do it tomorrow sometime, there is a challenge for you here. It's not difficult, but it will require you to go through what we just did. So if you want to try to do that, there's a little difference from what we did that it's going to put you in that mind state of seeing if you really understood the concepts or not. All right? So I think tomorrow we're starting at 4. Is that right, Luciana? Okay, tomorrow at 4. Really, this is a lot of stuff. You know, it's definitely way too much for 2.5 hours. If you guys have questions, please let me know. I'll be really glad to help. And if not, you're dismissed. And hopefully see you tomorrow. If I didn't scare you.